Thank you very much. All right, let's get started. Today we are going to be talking about constellations, right? Does anybody remember what a constellation is? First of all, Mr. Biggs, go ahead.
A constellation is that stars that make a shape.
Yeah, so they're stars, which, if you guys remember what a star is, it's that big ball of burning gas way up high in the sky, way up out somewhere in outer space, that makes its own light and heat. It does that because it's on fire, right? Okay, so we see that light, and that light shines down to us on Earth, and we see a picture sometimes if you look at the different shapes that they make when they glow in the night sky. All right, so let's get started. Moving on, constellations are pictures or images made of stars. If you did not write this down from our previous lesson, where we touched on constellations a little bit, write it down now.
I think I don't.
Okay, so I'll give you guys a second that are writing, and I'm going to be talking.
Write the whole page?
No, the only thing you need to write is this sentence right here, where it says, constellations are pictures or images made of stars. That's the only thing that you have to write down. Okay, so over the years, many peoples and cultures imagined pictures made up from stars in the night sky. Because of how Earth moves through the solar system, stars that are nowhere near each other in space look like they are closer in Earth's night sky. How is that possible? Who has a guess? Nobody? Well, guys, think about it. Even though these stars are sometimes millions and millions and trillions of miles apart, they appear to be close. Because the background of space is very dark. And all you see is that light. Yes?
Will the stars move?
Will the stars move? We're going to touch on that a little bit later. That's going to be covered. That's an excellent question. All right, so people in different parts of Earth see different constellations and at different times of the year. Make sense?
Yes.
How is that possible? Go ahead, Evan.
Because the Earth moves.
The Earth moves.
The Earth orbits around the sun, and if we orbit around the sun, we might see different stars from all around the sun.
Okay, so very good. That's actually quite quite close to it, right? Because the Earth has a tilt, and as it goes around the sun in its orbit, we see different things. Makes sense, right?
Yes. Yes.
You're not always going to see the same thing if you're on the other side of the sun. And you're tilted a different way. You're going to see a different set of stars. All right, so people saw the same stars in certain formations, and they made up stories about them, and they related them to stories that they already had. So, for example, who knows anything about, oh, I don't know, Hercules? Hercules! Who was Hercules? Nobody knows? Hercules was, in Greek mythology, he was the son of Zeus and a mortal woman. So Hercules was a half-god that went around the earth. He was a hero who went around the earth and did many different things. Yeah, very good. Yes. So, that's aside from the point, but they actually made up a constellation of Hercules in the night sky. They said, hey, that looks like that hero that used to go around the earth, saw fighting crime and saving us from disasters. Anyway, let's keep moving. So, what happens in the night sky? Earth is part of the solar system, which is in the Milky Way galaxy. Earth revolves around the sun, and this allows us on Earth to see different stars. Do you guys understand that? You don't have to write that if you understand that. This is only for you guys if you don't get the idea of seeing different stars in different times of the year. If that doesn't make sense, then yes, write this down.
Okay. If you want.
So Earth revolves around the sun, and this allows us on Earth to see different stars. That's the part that you should write.
Okay, I'll write it. Because you see the top.
You don't need to write it if you understand that. Okay, so imagine that the Earth is here and the Earth has a tilt, right? So as you're tilted and you're going around the sun, you'll see kind of the same stars, but depending on where the sun is, or not the sun, depending on where the Earth is, that Earth, the tilt is going to be different. So the stars are still going to be there, but you might not see the same ones. Because you're tilted either this way, so leaning towards the sun, or if you're over here, you're leaning away from the sun. Makes sense, right?
Right.
Grant, do you understand? Yes or no? Okay. So, don't worry, that's going to be covered a little bit more as the PPT goes on.
Not done.
You're all done, Jason?
Not done.
Not done. All right. I'll give you a few more seconds. You guys can see on this graphic here what I'm talking about. So obviously this is the sun, and this is the Earth. The Earth is leaned this way. That's its axis. Okay? So, if the Earth is over here, it's going to be leaning towards the sun. And if you're here, near the equator, actually no, let's go a little bit higher. If you're up here, you're going to be seeing these stars more than these stars, right?
Right.
Now, as you come over here, when the Earth is rotated away from the sun and it's nighttime, you're going to see more of these stars instead of these stars up here. You'll see more of the lower ones. Does that make sense?
Yes.
All right. Moving on. So, what stars do we see? I'm going to kill the lights here for a little bit. Kill them dead. All right, so hopefully that helps you guys see this. All right, there are all these different stars, and each and every one of these is a big old ball of burning gas far out in outer space. Okay. Earth revolves around the sun, but the sun and other stars are stationary, which stationary means they don't move. And as we know, that's not quite true because the whole Milky Way galaxy is moving, right? All of space is expanding. But for the purpose of this, for the purpose of constellations, the stars stay in the same place because the whole galaxy is moving together. So the stars are moving together. Everything's moving at the same space. You don't have to write this. The way Earth tilts and revolves not only affects seasons, but the stars that we see at different times of the year. This is what I was talking about just a second ago with the tilt of the Earth. Okay? All right. During the summer, Earth is tilted a certain way and is also at a certain place in its revolution around the sun. At this time, we see summer constellations such as Lyra, Cygnus, and Hercules. Alternatively, other seasons have their own constellations. Other constellations can be seen all year. So at nighttime, you can see different stars in winter and different stars in summer. That is true.
Do we need to write it?
You don't need to write that because you've kind of already written that.
Oh, and also,
Chelsea.
when you're at different part of the earth, you can see different part of the stars.
Yeah, that's true. That's true. We're going to cover that a little bit. That's good that you know that. All right, so that's what we're talking about right now. Hemispheres. So, hemisphere, if you take the Earth and you think of the Earth like, if you think of the Earth like a ball, okay? It's round. If you take the toilet paper roll, which is our Earth, and you cut it in half, straight away, right here. Careful, careful, careful. Can we continue?
Yes.
All right. If you take the Earth and you cut it in half, right like this, you have the northern hemisphere because it's north, and you have the southern hemisphere because it's south. You can also cut it this way and have east and west, right? But north and south. Now this is very important because if you're on the northern hemisphere, which is where we are in China, and also North America, Canada, England, places like that, you're going to see stars up here. If you're on the southern hemisphere, you're going to see stars down here. If you guys go on vacation, and let's say you go to Australia, or New Zealand, or Hawaii, you will be in the southern hemisphere. If you're in the southern hemisphere, you're going to see different star constellations at night. When I was, last summer, I went to, no, not summer, last Chinese New Year, I went to New Zealand. And in New Zealand, it's very, very beautiful at nighttime. And the reason is there aren't that many people there. So the sky is very, very dark at night because not everybody has lights and there's not a whole lot of buildings. There's actually an area called the Dark Sky Reserve, which is on the South Island of New Zealand. The Dark Sky Reserve is so dark at nighttime, when you look up, you can actually see the Milky Way going across the night sky. You can actually see the Milky Way, part of our galaxy, going across the sky. And probably, I don't know, 2,000 or 3,000 different stars.
What?
There's so many. Any questions about that?
Yeah.
Anybody have anything they want to say? Bill? So you cannot see all of the stars. You can only see what is available on the southern hemisphere. You're not going to be able to see the stars, a lot of them on the northern hemisphere, simply because you can't see through the Earth. Right? Chelsea?
Is it true that the south part has more stars than the north part?
I think that you can see more stars. I don't think that...
You can see more stars than the part. Like there.
Yeah.
The south part is more than the north part.
It kind of looks a little bit like that, actually. But, yeah, the south part, you can see the Milky Way galaxy. I think you can see it in the north part as well if you're in a place that there's just not a lot of people. Okay? But I know that for sure you can see it in the south part because I went there and I saw it. So, let's keep moving. Alright, and then we have these things called circumpolar stars. You guys don't need to write down circumpolar. Fati, get your head up, please. Let's pay attention. You don't need to write down circumpolar. But what you do need to know is that some stars and constellations can be seen no matter the time of the year. This is true. No, you don't. This is true because the equator. If you live near the equator, you're going to not move that much, right? So the constellations that you see will move and they'll shift a little bit up and down, but they're not going to completely disappear. Question, Elsa.
Well, I went to Singapore, and it's very near to the equator. And every night I just see that how there is in front of me every time I look up in the night sky.
Yeah, so if you're in Singapore, circumpolar stars. She says, I went there and I saw the Dipper every single night. You will see that every single night there. Because that star, or that group of stars, that constellation, is visible all year round.